Okay, video number 3. I just want to finish up the trig that's on the non-calculator part tomorrow. There is one thing about graphing on there. You are not going to have to graph. You do not have to find this. That'll be on the calculator portion. But what you will have to do is know a little bit about amplitude, period, phase shift, and what happens to graphs to compare. So what I mean by that is I might give you an equation like y equals cosine of x minus pi. So what you need to know is that that's getting shifted pi units to the right. So normally cosine starts up here at 0, 1, but now it's going to be jumped over to at pi 1. It's going to make one complete cycle. That takes 2 pi units to do that because nothing got stretched here. So it starts at pi, goes down, so at 2 pi it's down here, and at 3 pi it's back up there. So just to generally know, like, with shifting and reflecting, what happens. So then what do I mean, like, what would I ask? I might ask, is this the same graph? So then say, okay, if I started here and did this, let me continue this on, then this would go down at 0, go up at negative pi, and I could continue that cycle on. And yes, so if I think of negative, a negative cosine means if normally it starts at 0, 1, it would start at 0, negative 1, it would still have that 2 pi for a period. Nothing got shifted in this one, so those would be identical graphs. So that you could look at that and say, yep, those two are definitely the same answer. And then I could even throw a sign in there. I could say, maybe it's the sign, this would be shifted over pi over 2 units, because that's halfway between. So maybe it's y equals the sine of x minus pi over 2. That also would be the same graph, because it's a sine graph that got shifted over pi over 2. So just so you can compare, if I give you some equations, you could compare, are they the same or are they different? You don't have to graph them, you don't have to do anything else with them, just can you identify if they're the same or if they're different? Okay, so there is a question like that. All right, and then let's get into the vectors part. There's a question on vectors of can you find the position vector? So I'll always give you, be careful of which one's initial. I'll give you the initial point and the terminal point. So to find the position vector, you just have to take terminal minus initial. So, and you need to know that. You'll be given that. So when I look at this, okay, if Q is the terminal side, to find the x, I'm going to take 7 minus 3, that's 4, and negative 3 minus 8 is negative 11. That's all you need to be able to do to find the position vector. All right, there'll be some where you have to do scalar multiplication and adding, or maybe some magnitude problems. So if you have one like 2 that says, all right, first I have to take 5 times u, so u is right here, so 5 times negative 1, negative 5. 5 times 1 is 5, so I just put it in component form. That's what the i's and j's mean, the same thing as component form. Minus, I want to minus 3, negative 2. So I'm going to take negative 5 minus 3, negative 8, 5 minus negative 2, well, I'm subtracting a negative 2, I'm adding 2, so I got 7. And that's just my answer. So all I'm doing is I did a little scalar multiplication and then I subtracted. With this one, make sure you realize you first have to find u plus w. So I did that. I guess I didn't show that, did I? So I did that. Let's do that. U plus w. So if I take, and we might want to talk about that up here. There is no I term up here. So really that means the x component is 0. And the imaginary component then is negative 5. So there's no I value, but there is a j value. So when I'm adding these together, u plus w, negative 1 plus 0 is negative 1. And then when I add u plus w for the y's, negative 5 plus 1 is negative 4. So that's what I get when I added w plus u. And then now I need to take the magnitude. That's what those lines mean. So I'm going to take the square root of negative 1 squared, which is 1, plus negative 4 squared is 16. 1 plus 16 is 17. And since this is non-calculator, that's all you can do. Okay, so that means magnitude. All right, and then if we get to finding components of vectors, we give you the formula x equals r cosine theta and y equals r sine theta. You will be given that formula. So all you have to do is when you see this, that is the r. Remember, the magnitude is how long that vector is. So I just took 6 cosine of 30 for x and 6 sine of 30 for y. It'll be angles you know because it's on the non-calculator part. Cosine of 30 is radical 3 over 2, so that reduces. 2 goes into there 3 times, so 3 radical 3. Sine of 1/2, or 30 is 1/2, so 6 times 1/2 is 3. So in component form, that's 3 radical 3, comma 3. So, but you will be given that formula to use. Just know that that magnitude is your R value. Okay? All right, what else is on this piece? Jumping to parametrics. You have to be able to graph a parametric. So when you graph a parametric, I would just make a table. I didn't put the table on there, but it goes from -2 to 2, so I drew a table, -2, -1, 0, 1, 2. And it's going to be everything in between there, but just use those. Make an X and a Y column. So I just put in -2 for t. So in the X one, that would be -2 squared 4. 4 plus 1 is 5. I put in -1. 1 plus 1 is 2. Put in 0. 0 plus 1 is 1. Put in 1. So I just plugged in the t values for x. I went over to the y and I did the same thing. 3 times -2, -6. 3 times -1, -3. So I put those in here. These now become your ordered pairs. So I graphed 5, -6, started there. 2, -3. 1, 0. 2, 3, and 5, 6. So I graphed those. It is continuous, so it's going for all the points in between there. So I started here, I graphed it, went through, it should have went through 0, 1, doesn't look like it did very well, and it stops there. You have to show these arrows to show that that's the direction it's going. Remember, parametrics, the nice thing about parametrics is it has a direction. So you need to make sure you show that direction. So just make your chart, graph your points, connect them. This obviously is, squared, so you should see that you see a curve of some kind. If it's linear, then you should just see a straight line, but make sure that you show the arrows. Okay. What else? The only other thing I think that's on tomorrow's, that wasn't on that, but we've done it in the both reviews we did, was making sure you can find the product or quotient, and actually I'll tell you, it's just going to be the product. Find the product of a complex number. So we'll give you those formulas. Again, it's just, you're going to take R1 times R2, and then for the angles, you're going to add the angles together. That's the formula that you use. This, remember, is in polar form. So if they ask you to put it in polar form, you leave it like that. Remember, exponential is an E base, and you still have your angle, theta 1 plus theta 2, I, where these thetas then would have to be in radians. If you did it that way, you'd have to make sure the angle's in radians. Rectangular form is when it looks like this, square root of 3 plus I. All right, probably, let's talk about this one, and then I'll talk about making sure you can convert. So with this, if I were going to do this, I would get 12, right? Finding the product, so I multiply those two to get 12. And then add the angles, pi over 5 plus pi over 10. Pi over 5 plus pi over 10. That would be 2 pi over 10, so that'd be 3 pi over 10 would be the angle. So let's say it's set in an exponential form, and I'm multiplying and find the product of those numbers. I would get 12, and then I would get, it says in exponential form, e to the 3 pi over 10i. I'm just adding the angles when it says product. All right, so when it says like this one, when they're in rectangular form, you have to draw the picture. So this says I'm going to go square root of 3 over on the real part. The imaginary part coefficient is 1. So draw the picture. This would be 2. So I should know my radius is 2, and then I should know my angle. Again, to find the angle, sine is 1/2, cosine is radical 3 over 2. So that would be, what, pi over 6. And then I do the same thing for this one. I find what is the theta and what is the r. And then again, once you get those in polar form, then you're using this property. So you may have to convert, but then you're just using this property, and you only have to worry about multiplying. on the quiz tomorrow. And that should be everything on tomorrow's quiz, or on tomorrow's semester final. Why did I say quiz? Oh my gosh.